Okay, now that we have registered, stored the calibration factors of the analog inputs, we are going to show how to call these parameters, these calibration parameters, from our application. What we are going to show is something that is included in all the IRIS BOX PC units with a TESDA board. So all the code is free usable for the user, it is completely free and is supported by Surkey. So it is commented and it is developed in Visual Basic.net, VB.net, using Microsoft Visual Studio 2008. So this is an example of how to call the TESDA EA.dll library that we can see here, okay? And inside our code, what we have to do is very simple. We have to make within the project add a reference to the TESDA EA library.dll, right? So we can check here the different the call to this library, TESDA EA library, okay? Afterwards we have to call the init function of this library, right, to initialize it. And after that we have different functions depending on the value or the format of the value we want to get from the reading, okay? The first example shows how to get the input value in points of resolution coming from 0 to 4096 points, right? Okay, the syntax of the function is the one you can see here, and we have only one parameter, which is the number of samples that the function or the library will take in account to make an average of this acquisition. In this way we can use a bigger or a smaller value, and we will get the bigger we write here, the smoother value, and result the function will return to the code, right? So the return value is a double variable, okay, with a resolution ranging from 0 to 4096. All right. The next function is the milliamp function, EA milliamp MA function. Okay, the parameters we use is the first is the same in the previous function, which is the number of samples to calculate an average value. And in this function we can see that the calibration factors are required. So we have to give to the function the points of resolution corresponding to 4 milliamp input signal that we have got before at the calibration procedure, which is 757 in this case, and the same for an input signal of 20 milliamps, right? And we will get a double value with the milliamp input value of the signal ranging from 0 to 20 milliamps. All right. And the third function, the third way to get the input value of the analog channel in a different format is the one that gives us the value in engineering units. So in this case, again, a first sample number of samples value is required to calculate the average value. In this case, we have introduced 100. The second and third value are the same we saw in the previous function, which are the resolution points corresponding to the 0 and full scale of the signal. And the fourth and fifth value are the engineering units, the engineering values, corresponding to the 0 and full scale of the signal. So this function will convert an input value signal of these points of resolution as a result of the previous calibration we explained before to an engineering unit expressed value coming from 0 to 100%, right? And we will get it in a double value format. We are right now working in a new version of the library that will directly read the calibration factors from the TXT file generated automatically at the calibration procedure we saw before. So with this, we finished all the calibration procedure and hope to see you again in the next tutorial. Thank you very much.